Okay, so this is example 1 from section 2.7. It is asking for this equation of the line, of the tangent line at 1 of the function y equals x squared. So let's just remember what this graph would look like. So it looks like this, and then I'm drawing the point P. This is our point of interest, and I'm sketching the tangent line. This is just to give me an idea of where the line is going through and actually what the sign of the slope would be. So I noticed that this is going to have a positive slope, and it's going to have some y-intercept that I think possibly is going to be a negative y-intercept. So remember, for equation of a line, I need two elements. I need the slope and I need the y-intercept. So I can write my equation y equals mx plus b if I decide to do that. Or what would be the other form? Let's remember algebra 1 or 9th grade math. The other thing that I would need if I don't have the slope would be a point. Since this line is going through the point P, I might as well use my point P. So actually I don't need the y-intercept, but if I were to find it, I know that it's going to be a negative sign, and I can show you that actually later. So if I have the slope on point P, I know that my equation is going to look like this: y minus y1 equals parentheses x minus x1, and this is something that I already know. Okay, so I have the point P, but what I need is to find my slope. Okay, so by definition, I know that the slope is going to be the limit as x approaches what value? The x value of 1 of the difference of the y's minus the difference of the x's. So in here, the difference of the y's, what is going to be y when x is x? That sounds a little bit obvious. So I know that y is going to be x squared minus, what is the value of y? 1 over the difference of the x's. I know as x is approaching 1, this is going to be x minus 1. So this is actually f of x. This is actually the y coordinate of my point. This is simply x, and this is the x coordinate of my point. So that's how I set up this. You can refer to, let me see, page, this formula appears on page 143. Okay, so I noticed that the numerator can be factored, so whenever you see difference of squares, please take the time to factor that, and also take the time to write limit as x approaches 1 again. So I know I'm going to have x plus 1, x minus 1 over x minus 1. Why do I do that? Remember that I can't find the limit by evaluating if I'm going to have a denominator of 0. So because when I replace it, it makes my denominator 0, I have to find out a way out. If there is one, there may not be one. And we've seen that before. Okay, so these cancel out, and then I have, that's the same as the limit as x approaches 1 of x plus 1, and by replacing or by evaluating, that is worth 2. So the slope of that tangent line is worth 2. So that's it. This line that is tangent to the parabola at the point 1, 1 has equation y minus y1, in this case would be 1, equals 2 x minus x1, which is in this case 1. If you were asked on the test to find the equation of the line, this is an equation of the line, and that's all you need to show. However, if they ask you what's the y-intercept of the equation of the line that is tangent to y equals x squared, then you just have to simplify this equation. What's the y-intercept? So y minus 1 equals 2 times x minus 1. I just distribute the 2 to x minus 2, and then I add 1 both sides. So when I do that, I have minus 1. And you see the y-intercept is minus 1, as I had predicted by the graph. So it all makes sense. My slope is positive. and this is how I find it. Now, this is asking you for the tangent, the equation of the tangent line to that. If I say this problem in the following context, then it's just going to be the same thing. I could ask you the distance of a fly from a cupcake is given by equation y equals x squared. Find the velocity of the fly at time equals 1 second. So this problem that is about velocity, it turns out to be the same problem as the tangent problem. I have my equation. At 1 second, the distance is 1, whatever my units are. Let's say that these are, I don't know, inches. I mean, how far a fly can fly. I have 101. And then the same procedure will be the same. You will have to do the same to find the velocity of the fly at t equals 1 second. If I want to translate the same problem to a derivative, so this is about velocity. If I'm trying to change this to a derivative, then I will ask you, what is the derivative of y equals x squared at x equals 1? So in this case, the only difference between this kind of asking the question compared to the tangent one, in here I'm giving you a point. In here I'm not giving you a point, I'm giving you the x value of the point. You have to find what the y value of the point is. Well, if they give you the equation and they give you the x value, then by replacing you will find the y value for that, so that's not a problem. And also when I'm asking you for the derivative, I'm asking you for the slope of that line. But when I'm asking you for a tangent, most likely I'm asking you for the equation of the tangent line. So you have to go that extra step of finding what is the equation of the line. But when you're asked for derivative, you're asked for the slope of such line, not the equation of the line. So this is a shorter problem compared to the first one that we've done. And as an instantaneous rate of change, instead of saying finding the velocity, you could have been asked to find the instantaneous rate of change. You could see the same problem. I don't know, let's say that you have a bucket and it's filling with water. That's the faucet. Looks like a fly. But anyhow, the bucket is filling at, you have y equals x squared, where x is in seconds and y is, let's say, gallons. So you know that at 1 second, then there is 1 gallon. At 2 seconds, there is 4 gallons, and so on. So you want to know how fast the bucket is filling at 1 second. So at t equals 1 second, how fast is this filling? So you're being asked for the instantaneous rate of change when t is 1 or x is 1 or whatever it is 1. So again, it's the limit of the change in y over change in x, which is what you found over here as well. So the four things are actually just the same thing.